There's a lot of folks in the audience who understand what computer vision is, artificial intelligence, image recognition. There's also a lot of others that don't. So in a very simplistic one or two sentence from each of you, I'd love to hear your explanation to those in the audience that don't understand so we can be on the same page. Who wants to start? Gary, go.
This is what is computer vision and AI, and even, I mean, it's it's the difference between seeing and perception. That a bunch of waveforms are coming into some sensors, my eyes, and I'm creating semantic and organized meaning from that. That's usually for a purpose. It's in a context. In a robot, it might be to drive a road. For humans, it might be to interact in a social hierarchy. And so I'm taking that wavefront of energy, that's the seeing, I'm perceiving that, and turning it into a percept that is a structure of data that has meaning and actions associated with it.
So data that has meaning. Moshe, what would you say?
So, for me, it's the whole thing is not, it's not about technology really. It's about like the usage, what do people do with it?
Okay.
For me, for my company, when I started Photocino, which we did automatically organizing photos based on quality, like your auto-curation, it was always a problem, but when I'm not a vision expert myself, I have background, but I'm not an expert. When I went to expert with this, they all said that it's an impossible problem to solve. But what's not impossible is to use the technology in order to do something which is good enough, and this is what I think it's all about. So good enough, and this good enough is actually improving all the time. I'm seeing like the clarify thing with automatic tagging, it's amazing. So this is what all about, like getting that technology of auto tagging, of face tagging, and then applying it on an application that user can actually use every day.
Okay.
So is this working? Yeah. So one comment here about computer vision is it's an enormous field, and one way of sort of dividing what computer vision is about is into the 3 R's. So Roberto Cipolla and Jitendra Malik have these ways of dividing it up, and so these R's are recognition, reconstruction, and registration. The recognition is probably the part that most people here are interested in, like image recognition. What is it that's in this photo? Okay, and what Rob presented, for example, is at the forefront of the recognition part. Reconstruction, okay, that's geometry. Taking multiple pictures of things like tourist sites or of an object that you want to sell on eBay. That's reconstruction from multiple views. It's multiple view geometry. Registration, that's also known as tracking or lining things up. So this could be like when you're looking at a face and you detect some facial features on it and you want to match those facial features to some model. Now all 3 of these R's are connected, but if you look into the academic community, a lot of the researchers organize themselves into these groups.
Okay, great. So each of you are working on many different projects. Why don't you tell the audience in relationship to that response that each have? What's one of the projects or businesses that you're working on, either projects while you're a professor at Cornell Tech or Magic Leap or one of the other projects, Gary? And Moshe can tell us about, what is Photocino and how it relates to this panel. Okay? Who wants to start? Serge, why don't you start?
Sure. I have a project that's a collaboration with Pietro Perona at Caltech and Panos Iperotis here at NYU. The project is called Visipedia. The goal of Visipedia is to create something akin to Wikipedia, but for search by image functionality. And in particular, what we want to do is fine-grained visual categorization. And that might be for categorization into bird species, types of handbags, so it could be for visual commerce, it could be for citizen science. And as Flo mentioned earlier, a huge part of this is actually the community. So there are all kinds of incredible computer vision and machine learning algorithms that are out there, but they really can't do any good for us unless they've been tagged in a way that's meaningful, at an emotional level ultimately, that's meaningful to the community that wants to use them. So a huge part of the Visipedia project has to do with engagement of human communities who will actually be the users of these systems. This is very different than historically what happened in computer vision, which is where professors would gather their own data sets within their own labs, just with objects collected around the neighborhood or around their office. And that was nice for a benchmark, but it didn't really serve a community. With Visipedia, we're building these data sets for the communities that intend to use them.
Okay, great. Gary, you want to take it away?
So, I can think of like one of my key projects sort of spans everything I've done, and that is this registration. So I've never really been in this kind of web, okay, I want to just tag a photo or whatever. I always want to know the things I've done in robotics, and I also run this OpenCV. We have a lot of this key point feature detector descriptor. And now I'm in augmented reality, but all of these, they want to not just know, okay, so this smudge of imagery data, there's a cat in it. I want to know, where the cat is, how it's oriented, where the camera is, how motion is treated, and so that's been the main thing that, the main component of, between all these projects, robotics, AR, and I've tried to drive along the technology when things got stuck in SIFT features. Those are the detectors descriptors of like key points in an image. I did this article called Orb that was not patented and whatever, and that drove this whole new layer of development, and the current top feature is going into this free vision library I run, OpenCV, and it's accelerated K's features. I think those are the top performers now, but that's been this ongoing evolution, and we're also mixing this with 2D, like visual sparse flow, and with complete dense reconstruction. So
a piece of that you mentioned was understanding not just that it's a cat, but it's the emotion, the motion, and what's going on in the content there. I mean, so
it's where you are in the scene, where the camera's moving.
Okay, so like what's a use case? So how would that improve somebody's lives? How would that improve what's one use case that you'd like thinking about that relates to the value of that, which it's tremendously valuable, but
Google just bought it. We're grabbing boxes and automating distribution to get it to your house the same day you click, right?
Got it.
So to do that, you have to know not that it's a box, but it is a box, and it's oriented exactly in this way so that I can, basically, as they're doing now, grabbing a robot grabbing and moving 1 million boxes without one error.
Right.
So
it's always good to have the human use case so everybody in the audience can...
But I mean, personal robotics,
right.
Augmented reality, on and on. This is it's fundamental to anything that's not just an image on the web.
Got it. Cool.
Yeah, so for me, basically, there are two projects. So I start by just saying, like this, yes. We started Photogeno with a mission to basically be able to auto-curate and auto-organize all of the personal photos that you're taking. Like people are taking photos all the time, but then they're taking too many photos. Everybody was discussing this problem. So we built that technology and it worked, but unfortunately nobody cared. So You
mean nobody paid or nobody cared?
Nobody cared means nobody wanted to pay. Because I'm taking the photos for free, I'm storing it for free, everything is free. Why would I pay for you to curate my photos? You will tell me which photos are good, which photos are not good. A, I don't need you. B, I don't believe you. So why would I use it, or why would I invest in it? And that was a really miserable time. I won't bore you with the details, but. So what we took out of it is, okay, what are we doing what are we doing wrong, and what can we do with it? So what are the problems? The problem, again, is for people to preserve their memories. And so we came up with a way for people to preserve their memories beautifully, and using the app an app that we built on our website. And then we took it all the way to fully functional product creation automatically. So the problem that it's solving is that everybody wants to create products from their photos, but it's so complex and difficult and a long process, which only 5% are actually doing that. Also connected with who is the target customer, which is, I don't know if you guys know, but out of people who create products, it's 93% women, aged 25 to 45, 50 with kids. Men don't do it. So we had to go and build all of our technology and then create an app from it that would actually solve that problem. So with our app, for example, creating a photo book, which was a very complex thing before, timing went down from like 7 hours in average to about 20 minutes. And that's why, Shutterfly were really interested in this and eventually acquired the company. Now within Shutterfly, what we did since the acquisition, we were acquired actually 2 years ago, we embedded the technology all over the site. But the thing is that nobody knows about it. It's because users may feel that they don't want the photos to be created automatically. So the way that we implement it, again, it's a use case. You'll go to Shutterfly right now, you'll see that automated offer of products for you. The code name for that is Magic Shop, because all of the products are magically generated for each and every user.
What's an example of one of those that are magically generated?
Cups, mugs, iPhone cases.
So pictures on...
So what it does basically, users are uploading to Shutterfly all the time.
Right.
Our technology goes on the background, process the photos, analyze, selects the best ones, crop like the interest areas, finds like good materials to create from, and then we create like a beautiful photo book for you, or calendar for you, or mug for you. And this works beautiful. This actually generated a lot of incremental revenues for the company because it brought in a lot of different people, audience that said, hey, I want to create, but I never have time. So this is a very good example of how the technology works in the background. Nobody knows. Users don't understand how it works. They don't understand how the photos ended up on their calendar or an iPhone case, but they still buy it.
Right. Okay.
And the last thing that we're working right now, asking about project, is Shutterfly is launching a service called This Life this summer. It's now in beta, so and that's like preserving all of your memories ever taken, everything on one place, accessible from anywhere. The problem is that I have 80,000 photos there. So how do I find my best moments, my best stories? How do I go and find things that are interesting?
So that relates to this conversation.
So exactly. So we are now integrating the same technology in order to bring that value. But still, it's going to be a little hidden, because if you look at, for example, just one thing is Google Highlights. So what Google Highlights is exactly that. This is like, okay, these are all of my photos, these are my highlights, but it's very hard to understand. Users don't understand it. They don't understand like why does it look like this and how it got in there, and that's what we're trying to resolve.
So multiple different projects. Some of you work, probably Serge and Gary, there's multiple other projects that you're either on the board of, or you're advising, or people ask you to be involved in certain things. How do you choose? There's a lot of research and entrepreneurs out there, or people working on interesting businesses that need expertise. And how do you choose who to work with, or what to work with on these projects? I mean, are they usually ideas in channels that you are passionate about and then they fit? Or is it the people? Or is it serendipity? Or, in order to shed some light in the audience to help them figure out how to get the right people involved? I mean, how do you figure that out?
So let's see. I think one of the reasons I went into academia was because I liked working on lots of different projects within this area of computer vision and machine learning. And you find out pretty quickly, if you're on the tenure track, that it's kind of risky to publish outside your main area. You really need to define, okay, this is what I do. These are my home conferences. I need to produce results that are very easily quantified. And you produce nice plots, okay? And that's important. That creates the backbone of a lot of this technology. But I also have students or colleagues or just people that I meet at conferences or trade shows that have really interesting ideas that might have a much less quantifiable nature. So it could be something like what Moshe described with the emotional impact of a photo. Like, to what extent does this choice of cover photo summarize the 16 photos it was chosen from? So I think some of my criteria would be, if there's something I'm really curious about and there's a great team that's forming, and it's the kind of thing that just wouldn't be welcome or appreciated within an academic context, then a startup becomes an opportunity to do that. And I think as an educator, when it comes to teaching this stuff semester after semester, there are a lot of slides and techniques that just start to get stale. Like I remember Gary mentioned SIFT, and for years SIFT was absolutely the best feature. And last year this orb feature comes out, and one of my former students that Gary hired was part of this, and so that's suddenly the best feature. And that was not a result of an academic endeavor. This was something where people were doing real computer vision on robotics in a household setting, and SIFT was working okay, but they needed something more than that. So I think right now there's a very fertile exchange that's happening between industry and academia and computer vision. It's something that I didn't anticipate 10 or so years ago. It's just, some of the most exciting work is happening at these companies like Facebook, what Rob presented, or Willow Garage, where Gary used to be, and so on. So I just want to be tapped into that.
Got it. So really quickly before we go to Gary, it was one of the companies that you were involved with. Tell us about how you met the Anchovy crew and then the exit to Dropbox.
Sure. So Anchovy, this resulted as a sort of spin out of my collaboration with Pietro Perona on the Visipedia project. We realized that there were a lot of labs out there that were basically academic labs or maybe in pharma that had these image recognition problems that were very tedious. They involved a lot of repetitive work, lab techs sorting through images of stained cells and having to click on them and so on. And so the original idea with Anchovy Labs was to create this kind of hybrid human-computer system that would help these users do more with fewer clicks, counting cells, whatever, outlining tissue, and so on. So we really pushed hard, and we went into the summer at Highland Incubator. We did the NSF I-Core. And then at some point, we just weren't getting traction. And at the time, we didn't even know Dropbox was interested in photos. And then at some point, we just made this tough decision to pivot into a space which is very populated, which is personal photo album curation. And within a week, we ended up getting a call from Dropbox, and they were just looking. It was just a matter of timing. They were just looking to bring people on board to do that type of thing, and the visions were just absolutely compatible. So it's certainly not something I think we would have been intimidated to go out there and say, we want to revolutionize personal photo album organization. Yes, so does everybody else.
Right.
But we still put together a team that was passionate about a problem that allowed us to develop the technology that we needed. And then I really think we just got lucky with the timing.
Gary.
So mostly I just hire Serge students.
That sounds like a good process.
No, I stay tapped into a lot of professors because I do hire a lot of their students and/or find them in different paths sooner or later along the road. But
have you found anybody here yet? Got a couple more hours.
Maybe.
Good.
I've already, tried to move a few, but, I mostly, so I'm getting sort of increasingly involved in like being on the boards and, of things, and the ideas I actually, put more full-time into. It's mostly people. It's not the ideas, right? It's like, I would take good people and a bad idea way more than a good idea and bad people, right? You're going to go a lot further that way. So, and a lot of times, I don't know, what catches me is more like interesting people. So I did industrial perception, and one of my co-founders He doesn't look very good on paper. He dropped out of high school. He dropped out of college. He spent a year psychotic in a mental hospital. This doesn't look that good on paper. He's, like, I would work with him again at any time. As soon as he earns out of Google, I'm going back with him. He's great, right? So he was an interesting character. It was just over drug use that caused the psychosis. So it wasn't
Did
such
that
a,
help? Did that
you got to
help?
look over that. Well, often, I was.
Is that what you're suggesting to everybody?
I was in a research
Somebody
lab
tweet this.
where they had this.
Gary Bradski.
Yeah, they had this big thing about drug use. They're going to test for it, and I go, what? If they come out clean, I'm not hiring them. If they're not experimenting, they're not curious enough. But
So that tweet is going out. I can't wait. Who gets the photo as well? I think that's great. I mean, it's all about the people. I agree with you.
So, one of the sort of inadvertent nets I cast is I started this OpenCV, open source computer vision library. It's the largest computer vision library in the world. I built it from the beginning to be commercially usable. It's a BSD license and whatever. And so through that, I've met a lot of the vision community. We get 200,000 downloads, and this is a technical library. That is a
lot.
Who knows, 90% of all vision workers in the world are actively downloading this. So it's used everywhere.
Cool.
And so a lot of people come in through that, or they have some idea, or they're contributing. For instance, this guy, Ethan, who I co-founded, he was a contributor. Oh, that's doing good work, caught my eye. And, now he's a multi-millionaire at 21, working at Google until he earns out. That's the kind of thing. He's actually producing versus saying. So that's a big one. And if you're interested, I am trying to put OpenCV on a better financial footing. So, there's lots of ideas around that. Some of them good.
Cool. So Moshe, for a while you were focused 200% on your startup, right? And then sold, and now are there other projects or on the side that I don't mean new startups, but are you advising other companies? Are you getting involved more on that level?
Yeah, sure. It's all part of startup or entrepreneurship is what I did for almost the last 10 years. So you can't just throw all of that away and just go work for a large corporate. So and also it's also a lot of people help me with good advices and access to people. So he said it's just part of the Bay Area culture. So we try to implement the same culture in Haifa in Israel, even though it's so people help each other, and that's what I try to do. I help entrepreneurs. I help anyone that approaches me. Try to spend as much time as I can, really busy with all of the schedule of the flight and everything. Just related to your question about how do you pick the team, how do you select the team. So I came up with a great process for that. And they envisioned, I had a pitch, and then I think that's a great way to do is to approach, great technical institute. So, in Haifa there is the Technion, which is it's the Israeli MIT, very great pool of talent. So when I started, I went there and I had the thought process, and then I will talk with everyone, and then everybody will want to work for me, and I will choose the best people. That's what I did, and eventually I chose the one guy that was willing to work for free. And it worked out.
That was your co-founder for Photogeno?
Yeah.
The one that was working for free? Good.
So, yeah, he had to work for free for a long time.
So is that going to be, are you going to replicate that and do that the next time?
That doesn't scale.
It doesn't scale. So obviously, if there's any questions in the audience, I've got many more questions, but please raise your hand. So one of the challenges here is obviously the mixture of the audience, which is an opportunity and challenge. So image recognition, what is, computer vision, sometimes it's a fantasy to some people. So what I'd love to hear from both of you, what is one or two of the most exciting kind of human use cases that smart computer vision could help in 10 years? Or working towards that, we've talked about understanding either content in images or robotic technology with imaging, but think about one use case that you're like, oh my God, I can't wait for this to happen, with a base of what you guys are working in?
I think what I'm personally most excited about is assistive technology for the visually impaired. So think of it like there are bits and pieces of technology that are out there, like optical character recognition, pedestrian detection for vehicles. And so there's all sorts of detection and recognition technology that's out there. These devices, the wearable devices, are getting smaller, but there's this ever-growing community of disabled people that are kind of an underserved community. So there's a lot of technology that isn't really developed with them in mind, but the technology we have in our smartphones and in things like Google Glass and Narrative and so on have the potential to help not just blind people, but also people with cognitive disorders, memory, difficulty with memory. So I think I'm most excited about seeing blind people's lives or visually impaired people's lives change when they're suddenly able to read signs at a bus station, at an airport terminal, to recognize their friends' faces and so on. So I think that's a kind of transformative technology that hopefully kids, maybe 10 years from now, will just take for granted that it was always that way.
So on a further, vector in that direction, I think there's a lot of stuff going on with the brain. There's optogenetics, where you're now able to fully instrument. This is happening all over. This is the technique of, you're able to fully instrument the neural pathways and turn them on and off. And there are, and then there's also ways of visualization of which systems are active. And so this is going to really produce advances in the brain, which will be fundamental in curing, a lot of what ails humanity. So one of these is the connectome. It's just like, so if we can describe all the pathways in the brain, we can start at least learning at some structural level what is happening. But with these other like dynamic technologies like optogenetics, with other ways of fluorescing, so we can actually visualize and then turn things on and off, I think that would be a really rich area that'll have a huge impact on humanity. Beyond that, there's robotics stuff, but. Okay,
great, Moshe.
So for me, there are two things, basically. There is one kind of a personal thing, and the other one is more for the humanity. So the personal thing is that I have a 8 years old daughter, and I have a bet, like, a bet with a lot in stake, against one of my friends that...
you have a bet with your 8-year-old daughter, or with a friend?
With a friend that my 8 years old will not have to learn how to drive when, she'll be 17, which is...
Huh.
I think that's where the world go. I think that, in 10 years, nobody will know how to drive and it's all be automated. That's one thing. The second thing, which is more like a vision...
And that's based in computer vision.
Yes.
So obviously the car is photographing everywhere, just so everybody's on the same page.
Right.
It's photographing everywhere and translating to obstacles, lights, etc.
Right. And I think actually, technology-wise, we're very close. So, those Google cars can do almost that already today. So it's a matter of regulations and stuff like that, but we're very close. The technology is close to do that. The second thing for me, again, just looking at from the disability or, helping perspective, but for me it's more like, making the world like a much safer and just place where, I envision, and again, I admit it's a little creepy, but I envision that there will be cameras everywhere taking photos of everything which is going on all the time. And any like a violence act or a criminal activity would immediately trigger something that would get stopped at. So we'll have those in school where, people are, kids are bullying other kids. Immediately we'll be able to interfere or criminal activities like robberies, everything. It's like a minority report, like a real-time thing. But again, also for that, I think that the technology is not that far from achieving that.
So just closing out, our time is almost done, and we could go on for a while talking about potential use cases of image recognition and computer vision. there's a lot of, discussion of are entrepreneurs, do they have a certain DNA, do they not have a certain DNA? Do researchers have a certain DNA, do they not have a certain DNA? And the opportunity to have more researchers and or brilliant people in school, Serge, you and I talk about this a bunch, at the right time, starting to take the technology out of universities and partner with universities to build businesses. I'd love to hear really briefly from each of you quickly, if you can say kind of if you think that's a good idea, and if you think it's a good idea, what's the one sentence advice to help people make that leap?
So I think it is a good idea, and I think that the tech transfer offices at a lot of universities are broken, and I would highly advise that they emulate what Cornell Tech is doing, which is much more like a startup incubator. Cornell gets an equity stake, a few percent. They put in seed funding. People can start companies. It's very simple. It makes sense. So I think a lot of universities are going to come around to that model. But right now it's steeped in this kind of old, broken tradition, and it makes a lot of inventors just want to get away from the university. So I think Cornell Tech is a leader in that regard.
Okay, Gary?
I've seen people be quite successful on a kind of 10-year plan where they very systematically went after something. And I think, a lot of companies launch too early and they're sort of foolish that you sort of select where you're going to go and learn something. You might already get rich if it's lucky, but you learn a lot from certain companies and certain situations. Even big companies, it's good to do at least one stint in a big company. And so, but I've seen people who very systematically did this. They got experience, whatever. They got then a PhD, not because they cared about the PhD, but they were going after a certain technology. They ended up with an IEEE best thesis, but it was only because they were going after a purpose, right? And so they did even better at it. And now, they're making a lot of money off of this, and it'll probably be a buyout soon by one of the big companies.
Moshe.
So to me, the environment is already there. So yeah, there are some broken things in the universities, but today, this is like heaven for entrepreneurs. It's very easy to be an entrepreneur today. You have so many supporting systems.
Well, I think coming from, isn't it, the mentality or DNA for most researchers is not to build a company, historically. And so do you believe that's changing? I mean, that's kind of, it seems to be a smaller percentage will then go and start companies. Maybe it's different in Israel, I don't know.
It's at the end, it's statistics. So some of the people are like that, some of them are not. I feel, very connected to what Serge just said about sometimes the university give you the opportunity to go do that, so it's easier. But when you are convinced, again, to me, the number one characteristic for a successful entrepreneur is persistent. Mm-hmm. If you're persistent enough and you are convinced, then you'll do whatever it takes.
All right.
You'll leave your university position, you'll go, you'll build it.
Okay, on that note, thank you very much, guys. Fantastic, round of applause.